Working principle of DC motor. Working principle of DC motor is very simple. We can see that when the current conductor is placed in magnetic field, it experiences some force in particularly direction. The very basic construction of a DC motor contains a current-carrying armature, which is connected to the supply and through commutator segments and brushes. The armature is placed between north and south pole of a permanent or an electromagnet. An elementary model. One single turn of conductor is placed between two opposite poles. If we start to supply DC via commutator system, current will start to flow. As we see, positive terminal of a battery is connected to left conductor of a turn, and negative terminal is connected to right conductor of a turn. As we see in model, north pole of the magnet is placed near left side, and south pole is placed near right side of the turn. Current in left side flows inward, and current in right side flows outward. As we see, conductor is carrying current and they placed in magnetic field. Both of them experienced mechanical force acted on them. Direction of mechanical force can be easily determined by applying Fleming's left-hand rule. To do this, spread out your left thumb, forefinger, and second finger so they are all at 90 degrees to one another. With that, if the forefinger is aligned along direction of magnetic field, from north pole to the south pole, and second finger is aligned along direction of the current and left side conductor, then thumb indicates direction of mechanical force. Similarly, if the forefinger is aligned along direction of magnetic field, from north pole to the south pole, and second finger is aligned along direction of the current and right side conductor, then thumb indicates direction of mechanical force. Due to this upward and downward forces on the turn, one torque is produced when turn rotates on clockwise direction as shown. After rotation of the turn comes to vertical position in respect of the magnetic field. At this position there is no current in conductor because turn, conductor and brushes rest between two commutators. Hence, there is no force acting on conductor, by due to moment of inertia, turn continue to rotate, and comes horizontal again. Position of conductor has been changed here. That means conductor which was previously in left position comes to right position, and which was previously in right position comes to left position. At that position, we can determine mechanical force with applying Fleming's left-hand rule. Let's do that. To do this, spread out your left thumb, forefinger, and second finger, so they are all at 90 degrees to one to another. So if forefinger is aligned in direction of magnetic field, that is, from north pole to south pole, and second finger is aligned in direction of a current in the left side conductor, then thumb indicates direction of mechanical force. This is clearly upward here. So if forefinger is aligned in direction of magnetic field, that is, from north pole to south pole, and second finger is aligned in direction of the current in the right side conductor, then thumb indicates direction of mechanical force. This is clearly downward here. Do this upward and downward forces, turn, tends to rotate in clockwise direction. From that explanation we can come to conclusion that, here in this model we can see that, whichever conductor comes near south pole, experience upward mechanical force, and near north pole, downward mechanical force. And do this continuously forces the mechanical turn rotate, even if battery is not connected. Particularly DC motor rotates at the same principle like this elementary model. Instead of single turn in DC motor we have mountain turns on major coil. And instead of 2 poles there is number of poles installed. I hope that you like it. Please subscribe, like, and leave comment.